with alternating current, our magnetism portion is left that we have to discuss, and we'll be discussing. So do not worry about that. We'll be discussing that portion because, just wait. Taha, same thing for you. Taha, Taha, you studied this portion with me.
Yes, ma'am.
Yeah, Taha, join the next meeting directly.
Oh, okay, ma'am.
Okay, Taha, you can
Okay,
directly.
thank you.
Yeah, Memuna and Zara. You both pay attention because this chapter you both have not done it, and we have this chapter as a very important chapter. And since we are not going in the sequence, so some things need to be repeated by me that I'll do. But there is no such very hard and fast connection with that you all need to continuously apply or just understand. Okay, whatever will be coming, that I'll tell you in between. Okay. Now, see, basically in the chapter current electricity, whatever we have studied, whatever portion we have studied in current electricity, the current is actually your direct current. That current is called direct current, whose short form you might have heard DC current. DC current is said. So DC basically means direct current. Now, what is meant by this direct current? See, when we were studying current electricity, at that time, we had seen that one value of current was given to us and that value was fixed throughout. Like if there was a question, the question said, let's say current is equal to 5 amperes. So throughout, we used 5 amperes only in our numerical. Was there ever a situation that in the first line you were using 5 amperes, in the second line you are using 10 amperes? You're doubling it. Or using 15 amperes, you're tripling it. No? Yes or no?
Yes, ma'am.
Right? We never faced a situation where we had to use the current in a way that is continuously changing, or the value is changing, or the current is depending on something and the values are changing and the time is increasing. Nothing happened like this. We had a particular value of current and that value was used throughout the question. That is the first case which you have to understand. So suppose, or what we have seen that suppose I started the timer at t is equal to 0. Okay, I've started the timer at t is equal to 0, and what I am seeing that the current is, let's say, 8 amperes. This is the question given. The question will not, this, or the question can say that after t is equal to 5 seconds, value of current is still 8 amperes. This is possible that the value of current is still 8 amperes. Fine. let's say at 10 seconds, this is 5 seconds, this is 10 seconds, current's value is still 8 amperes. Means the values of current which we are facing, all these values. What are these values? These values are nothing but the constant value of current throughout. So if I have such an equation where I have a time on one axis and I have current on the other axis, what can I say in such cases if I have current and time? Can anyone see what kind of relationship do you see here? Between time is there, current is there.
Current is constant with time.
Do you think when the time is increasing, current is increasing? So here, what will happen? Current's value is fixed 0 seconds, 5 seconds, 10 seconds, 15 seconds. The value is fixed, 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 and it's fixed. This is the value of the current which is fixed. Okay, this is the value of current which is fixed. So what is happening here? Current is not depending on any variable, not even time. It's not even depending upon the time. So what can we say? What is direct current? When the value of current doesn't change with respect to anything, not just time, but most importantly, time and nothing else. Now let's come to the next section. What is alternating current? Because direct current we have studied. Now, when these values of currents are not fixed, like at 0 seconds, value is 0. At some second it is increasing, at some second it is increasing, then it is increasing, then it is reaching a maximum value, then it is decreasing like this. Then further it is decreasing like this. This is a crest, this is a negative trough. Basically, the current is changing. Alternating, the term alternating means changing. Means the current is changing. And how is it changing? Class, this form of graph, this wave that has been drawn. Okay, this wave that has been drawn, this wave is basically the sinusoidal wave. Okay, so this is the sinusoidal. Basically, what happens here? This graph that you have obtained, this graph is nothing. This is just showing that this is varying sinusoidally. What is meant by sinusoidally? Sinusoidally means function of sine. What is the sine? Sine theta, sine x, sine omega, sine theta. This is how we have been using it. That's exactly what is this alternating current all about. Sinusoidal means changing with respect to time. It can vary in any manner, or it can be a cosine graph. Means function of cos theta. Okay, write it till here. Okay, let us discuss the AC dynamo. That is the first topic which we will be including. Remember, fourth chapter, fifth chapter, and sixth chapter also we have to do. So we will be doing it after this. So some concepts are there from EMI that I'll discuss it. That's why the sequence is important. The sequence of NCRT is important. First you study electrostatics, then you study magnetism, then you have electrostatics and magnetism together, which is your EMI. So anyways, okay, since we have started, let us complete this. So what is an AC generator? Basically, AC generator you can say, or AC dynamo you can say. So this is basically a device that converts, see, it converts mechanical energy. What is meant by mechanical energy? Mechanical energy means sum of kinetic and potential energy. Though mechanical energy means total energy which is existing in your system. So majorly we have two kinds of energies existing. Due to change in motion, we have kinetic energy. Wherever there is production of velocity or change in velocity, we have kinetic energy. And wherever there is conservative or wherever there is conservative interaction, means forces are being exerted and two objects, bodies, charges, anything, they are able to interact, means they are able to exert forces on each other. And there is a change in orientation, position, shape, size of the object. We say it is the potential energy which is coming into existence. So sum of kinetic energy and potential energy is known as the mechanical energy. So AC generator basically converts mechanical energy into the electrical energy. And this electrical energy is actually your AC current. Okay. Now, it is based upon the Faraday's principle. So, Faraday's law, Faraday's principle, we'll be discussing in detail. For that, you should just know. See, Faraday's law said that magnetic flux basically means that number of magnetic field lines which are crossing area perpendicularly. Means if suppose I have this plane surface and this magnetic field line is crossing, and that too with an angle of 90 degree. So we will say that the magnetic flux here will be 1. That is what is meant by magnetic flux. We'll have a proper discussion on this because this is important, magnetic flux. Right now, do not focus so much on it. Focus on the AC alternating current part more. So it is based on the Faraday's law. Now, Faraday's laws basically means EMF you already know. You have studied current electricity. So it says that EMF, it will be induced in the coil, and EMF is actually equal to minus rate of change of flux. Okay, rate of change of flux. This you should know. So basically in an AC dynamo, magnetic flux gets changed in the uniform magnetic. How it is constructed? Look at the construction first. See, two permanent bar magnets are present. Permanent bar magnets. Okay. These magnetic fields are then coming from, see, from north to south, from north to south. This is a rectangular coil which is present. Okay, this is the rectangular coil. It can be a circular coil also, but most probably we have the rectangular coil. These are these small slips, these which you can see, the rectangular minute part which is holding it. These are called as the slips. They connect. See, these are two slips over here also. These are two separate slips. They finally connect it to an armature on which it is resting. Okay, all these things are present. So what happens, since we have not studied EMI, we basically have a concept of torque. Let me tell you this. We have a concept of torque in rotation. So the formula of torque is B dot A, not B dot A, sorry. Magnetic moment dot magnetic field, M dot D. Now further magnetic moment is current into area. area into current. So this becomes current into area B. And if n number of turns are present, then it will be NAIB. So this is the case of or the story of a torque. So basically what happens here, these magnets are present. Due to magnetic field, this torque is created. So when the torque is created, it allows the rotation of the coil. And different angles are produced, different deflections are produced, different angles for magnetic flux are produced. Okay, that is how it works. This much is important. Now regarding the angle and everything, we'll be discussing it. Okay, we'll discuss it once we have, or once we are through with the EMI. First, write it down till here. See, N is the number of turns in coil, A is the area of the coil, V is the magnetic field, and omega is the angular velocity. Angular velocity means the velocity with which the coil is rotating. Now, since we have not done flux, but the formula of flux, I'll tell you, it is actually B dot A. That is BA cos theta. Now, since N number of turns are there, so I'll put it as N. Flux is equal to B dot A. This is equal to BA cos theta. Okay. What is phi? Phi is the magnetic flux. It's not written here. I'll write it here. This is the magnetic flux. Now see, omega, angular velocity is basically linear displacement by time. So angular displacement by time. Angular velocity is angular displacement by time. So angular displacement is equal to omega t. Let's put this value here. So phi is equal to NBA cos omega t. Now I have told you one thing, that the formula of EMF is minus d phi over dt. Correct? D phi means we are differentiating. It means d phi over dt means you have to differentiate NBA cos omega t. This you have to differentiate. Now class, remember, when you are differentiating trigonometric functions, if you are differentiating sine theta, sine omega t, it will become omega cos omega t. And if you are differentiating cos omega t, it will become minus omega sine omega t. Remember it like a rule so that you remember how to differentiate it. Integration also I'll tell you later when we'll come to the integrals part. So on differentiation, what will it be? Minus NBA, these are common. Cos omega t becomes minus omega minus omega sine omega t. So what is the final value of EMF? See, NBA omega sine omega t. Can you notice class, in the formula of EMF only we are getting time. Means as the values of time will be changing, we'll be getting different values of EMF. Suppose two equations are there which you should understand. Before that, if I say sine omega t means this angle. Treat omega t as an angle. Don't treat it as angular velocity or something. This is angle for us. So sine omega t, if this is equal to 1, it means omega t will be equal to how much? When is your sine theta equal to 1? What is the value of theta then? Yes, class. When is your sine theta 1?
90
90.
degree.
Yes, very good, sir. It means omega t is 90 degree. So what will be the maximum value of E then? If this entire term is 1, it will be just NBA omega. This is called the peak, the maximum value. This is the maximum value. See, maximum value is omega. So you can write this as E naught. E naught means the peak value. Sine omega t. Similarly, current will be written as I naught sine omega t. These values should be remembered, and this is the maximum value which is possible. So if you plot the graph, sinusoidal graph, you can see there's a maximum value of E, which is NBA omega, and a minimum value. So this is plus, this is minus. This is how the graph is made. write this as well. Done?
Yes, ma'am.
Yes, ma'am. See, class, of course, the entire derivation we will not be able to do it in one go together. So, just few things that are required for any derivation in this chapter. Firstly, we'll start with the value of current. So this is not a DC current. See, I naught sine omega t. Now, class, clearly you can see that sine omega t. This simply means that time is changing, so current's value will be changing. But what you have to focus is on this. What is this? This is basically the peak value, okay? Or we say this is the amplitude. All these words will be coming. Amplitude. Or simply, very easy, the maximum value. Okay, so the maximum value. Now, whenever we are starting the derivation, you should be aware of the fact that current is equal to dq over dt. And when we are finding out the charge here, see, the finding of charge will give us the value of the current in this chapter. What will it be? If it is differentiation here, it will be integration on the other side. Okay, it will be integration on this side. Why? Because C class, differentiations operation, inverse operation is integration. And if it is half cycle means if this is the graph, total time period is T. Okay, total time period is T. In this also you can mark that T is the time period. So if we have T, it will be the time period. Okay, this will be the time period. Time period means the total duration from the initial point to the final point. Now this pattern will be repeating. This is the total time. But if we are calculating it for a half cycle, our time will straight away be T by 2. That's it. This derivation further I'll continue. First you copy till here because we don't have much time for this derivation. You write it till here. Text me done in the chat column. Okay, Maimuna done. What about Zara?
Done, ma'am.
Okay. Class, from here, continuous derivations are there, which I want to discuss with you. So on Tuesday, I'll be discussing those derivations with you. Those derivations are very important and they come as it is. So please prepare and revise till here, because this is a little difficult chapter if you do not revise it. And if you revise it, the chapter is very easy. Actually, it's very easy. Okay. So let's meet in the
Okay,
next
ma'am.
class then, with your doubts and everything. Okay.
Okay, ma'am.
Okay. Thank you so
Okay,
much.
ma'am.